Hello, everybody. We are live. We're just going to give it a few minutes to allow people to join. All right, so let's give it maybe 1 or 2 minutes. Hello. Y'all excited to build a game of 2048? Okay, let's give it a couple more minutes. Just get people to join and we can get started. Okay, awesome. Make sure you all check in on the Discord as well. There's a link in the Discord. Please check in on there and we'll get started in just a minute. Okay, let's get started. There we go. Can you all see my screen? Just fine. Yes, no. A little bit of stuff on there, but we will get to all that in just a moment. Okay, can you all see my screen? Just put in the chat, yes, no, maybe. Okay, awesome. Let's get this started then. Perfect. That's great. So, you all might know what the game 2048 is, right? Anyone here not know what the game is? It's essentially a game where you sort of swipe tiles around the screen, and the whole point of it is to get to the number 2048. So you have random tiles that appear on the screen. It's usually 2 tiles at a time, and what you want to do is swipe the screen in an order where you get to the highest possible number. So you start off with either the number 2 or 4, and every time the number collapses in onto a number that is the same as itself, then the um, basically your score increases and you have the number doubled, right? So if you have 2 and that collapses into a 2, that turns into a 4. If you have 2 4s that collapse into each other, that turns into 8, and so on and so forth. All right. So before we get coding, we need to first define the different parts of the game, right? So there's obviously going to be the game GUI, right? So just the game UI, and we're going to be using tkinter for that, right? So tkinter, that's basically a Python library which has a lot of UI elements and makes building things like that much easier. And in this, we obviously want to have a title slash the score, right? We want to keep score, and we want to have the actual grid in which we're going to be having the game take place. Next, we also want to make sure we have all the key bindings in place, right? So right is right, left is left, and so on and so forth. So the key bindings are going to be essential, as well as the different colors and fonts. So if you've ever played the game before, you know that each of the tiles have a different color depending on the number that you're at, and then an empty tile has a color. And we also need to obviously define the foreground and the background colors. So that's also going to be happening. And then the fonts as well. So fonts and colors for everything is something else that we need to define, right? Next is the actual game, right? So can anyone in the chat tell me what are some actual game elements that we need to take care of over here? Y'all can type anything you want, just parts of the game which we would need to account for in the code itself. So I can get us started on that. We obviously need a 4x4 matrix, right? And this sort of 2D array is what's going to be, uh, this is what's going to have all the rows and the columns in it. And we're going to be doing basically a bunch of different matrix manipulation functions on these to get to the final result, right? So we have a 4x4 matrix. What else might we have? Just throw things out. Doesn't matter what it is. Anything works. Oh yeah, of course. If you haven't coded in Python before, that's not an issue at all. It's very beginner friendly. I'm going to be going very slowly. I also do have a GitHub repo that has sort of just the initial skeleton, and that will be updated as we continue throughout the stream. The numbers or the score, that's correct. So we do need to update numbers and update score. Those are some things that we need to do. That's good. What else? And that's pretty good. Some other things we need to do is actually have the game start. So just the start game function and initializing the game, right? We initialize the game. As you said, we need to initialize the score, all the different matrix manipulation functions. So yes, that would be the ability to move. So and that will include a bunch of things, right? So you have left, right, up, and down for that. And now each of those are going to operate differently. So one might be the reverse of another, right? And if you're moving all these tiles around on the screen at the same time, you need to keep in mind how sort of a matrix would be affected in that way. So moving left, right, up, or down would change based on also everything that's on the screen, right? Um, Something else that you need to do is randomly add tiles after each move. So that might be another part that we need to take care of, right? So randomly adding tiles. And what else might we need? So something else is just checking if the game is over or if there's still room to move, right? So check, oops, check if game is over, and the game is usually over in two situations, right? So the first situation which a game might end is if the user wins the game, so the user gets 2048 tile. Otherwise, if there's no tiles left, right? So there's no moves possible, no possible moves left on the board, then the game is also over. And this is when the user loses, and this is when the user wins. So we need to, oops, wins. So we need to account for both of those, and we need to create banners accordingly once they either win or they lose. What else might we need? So something else we might want is, yes, the UI, definitely the UI. That's a important one. So just UI. So this is both, I guess, initializing it, right? So we need to initialize the UI. And then on top of initializing the UI, we also need to update it. So because we are going to be doing all the manipulations on a matrix, everything that happens in that matrix needs to show on the UI as well. So that would be all the UI updates. And then relevant buttons and functions. Yeah, that's correct, for starting the UI and everything. All right, that's good. And then let's see, we have pretty much everything. I guess the last thing is also just the general matrix manipulation functions. So again, because we are working with matrices here, there's some like linear algebra terms that might pop up, but essentially we need to learn how to stack each of the tiles, right? So if you have each individual tile, you have a 2 next to a 4, and the 4 is to the right, and there's like a gap between the 2 and the 4. You need to be able to move the 2 next to the 4. So doing that shift, we need to do that shifting or that stacking. So we'd have like a stack function. And then if they're both the same number, we need to be combining the two. So we need a separate combine function. Then there's also reverse. If everything is on the right and we are going to the left, that's essentially reversing the order in which everything is. So we need a separate reverse function. And then lastly, it's like a transpose function where if you have all the tiles on the bottom and you want to move them to the top, then you would use a transpose function. All right, so that is pretty much all we need for that. And really quickly, I'm going to put the GitHub link in the chat. Okay, so this is the GitHub link for the 2048 game. I will continually update this as we go on. So if you have to step away and you come back, then I'll try updating this as often as possible so that we have the game sort of update live on the GitHub repo as we're doing it over here on the stream. All right, so let me just add everything just to read me. Okay, so now this README should have gotten pushed, and you should be able to see that on the GitHub. And yes, it is. Okay, perfect. It is there. All right. Is everyone following so far? If someone wants me to slow down, speed up, just let me know in the chat. All right. We can take care of that. Okay, y'all ready to go into the actual game, coding the actual game? All right, let's do this. So we have a main function here. This is just print, this is sort of a placeholder. Oops. And this is just the initialization function. So the first thing we want to do is the import statements. So there are two import statements that we need. First one is the tkinter library, and this is to basically access like the frame, the UI widgets, all of those things. We're going to be using tkinter for that. And then also import random. So this is so that we can get different tiles showing up randomly on the screen. All right, so we want to first of all create a game class. So we can just create a game class over here, class game. And in this, we're going to be passing in a frame from the tkinter library. So tkinter.frame, okay? And then we need to initialize it, so init. And in this, we're going to be passing self, okay. And then you want to actually initialize the frame. So tkinter.frame dot init. So you're initializing it, and this would be self. All right. So this is just a lot of initialization work. There's no really logic that's being done over here. This is all specific to the tkinter library. And if you all would like, you can go into the docs and check it out in more detail. But this is sort of just setting up all the UI, setting up the widgets, setting up the frame, things of that sort. So there isn't anything extremely important happening here. It's just initialization for everything. So something else we need to initialize is the grid in which everything is going to be taking place. So we'd be initializing it like this, and this is how you initialize a tkinter grid. And then we want to set a title for our game as well. So for that, we write self dot, this would be master dot title, and then you just set the title to whatever you want. I'm just going to call it a simple 2048. You all can call it 2048 by your name or anything else. All right. Next, what we want to do is actually create the main grid. So for this, we need a background color, we need borders, and we need the width and height. So this is essentially just setting the frame itself. And for this, we can call it main grid, so main underscore grid, right? And then this we will set to tkinter.frame, and we pass in self value, so self, comma, and then you need a background color over here. So the background color, I have a copy of the hex code for the background color. That would be hashtag, I just copy pasted it. 92877D. This is sort of like a default. This is a gray background color. Let me show you all right here. So it's like this grayish, it's dark grayish background color, grayish brown. So this is just a background. We're obviously going to be creating things on top of it. So it doesn't matter too much what this background color is. You can make it whatever you want. You can make it a very bright blue if you'd like something darker. Not a huge issue. So we've set the background color. Now we want to set the border. So that would be BD equals, and this would be 5, setting the border to 5 pixels. We don't want it to be too wide or too narrow. And then the actual width and height of the frame, we can set to 800, as it is going to be a square. Height also equals 800. Okay, and that's it for that. So again, this was just a lot of initialization work. We still need to do quite a bit of initialization work, but we will get to the real coding very soon. All right, now that we've gotten that, are there any questions so far? Or is it pretty straightforward? I'll just wait for questions to come into the chat. Anything? Y'all are good? Oh, we got a little banner going. Okay, perfect. And then I guess we can continue. And if you have a chat or if you have a question, just continue putting it in the chat. I'll keep monitoring it from my other screen. Okay. So now that we've actually gotten a bit of the framework done, this thing will not run yet because it hasn't been properly initialized. So we need to next create the main grid for our program. Let's see. There we go. So main, I do not like this. Okay. So this would be self dot main grid dot grid. So this is the grid in the main grid, and we're going to be padding the Y value by 110 pixels. Now this padding is for the score header. So we're gonna have a score and the score value, and this is what this padding is for. And I can show you all that really quickly. So essentially this is what we're trying to make right here. And the padding that we just created was this up here. So the space for the score. Also, you saw we already set the title. That title is this little 2048 over here. Okay, so that's sort of what we've done so far. We have this empty frame, we have a score value, we have the score number, and we have the title. All right, are you all following? Okay. So we've gotten the Y value done. So this is the padding on the top. Next, we need to make a few functions. So we'll have a few placeholder functions right here, right? So over here, we need to actually create the GUI, right? That's something we need to work on. We need to work on actually having a sort of start game function just so that the game runs. So start game function. And then we need to have all of our key bindings. Those will be done over here. And lastly, we'll just have this main loop running. This is a tkinter thing, so self.main loop, main loop. There we go. And this is just to ensure that this thing keeps running and the tkinter frame stays up. So We can actually start with the key bindings. That should be pretty simple. That's just binding the left key to the left key, right key to the right key, uh, up key to the up key, and down key to the down key. So this is for the arrow keys. So that's pretty simple. You just need self.master.bind. And over here you do the left key with self dot, oops, let's shift that over, self dot left. Okay, and then you just do the same exact thing for right, up, and down. So forgetting this close caret. Okay, left, right, self dot right, up, and self dot up, and lastly down, self dot down. And this is just the key bindings. All right, and then we have our main loop over here. Then lastly, okay, so what we've done so far is we've finished all the initialization work, right? This is essentially just setting everything up. It's saying, okay, we are going to, this is the frame, this is the title, this is the background, dark background, this is the padding, setting all of that information into a main loop. And then we're going to get to creating the GUI and starting the game function shortly. All right, next there's going to be setting, as we had in this README, we said we need to set all the different fonts and colors, right? Now this is a really painful and arduous process actually, because you need to set the color for each number and for each, basically for everything that's going on in the frame. So what I'm going to do is I'm just going to copy and paste it over from another source, and this source has it so it matches, it's matching the actual color as closely as possible. So I'll push this to the GitHub shortly, but so y'all can get it from there. But essentially what's going on here is this is just the color of an empty cell. So if a cell doesn't have any value, this is its color. And then each cell also has a number that's on it. This is the font of that. They have a font of the number. This is the font of the score label, the font of the score specifically, game over font, the color of the game over font, the background of the winner. What is this thing called? The little window that pops up when he says, oh, you won, and so on and so forth, right? And this is the color of the different cells. So depending on the color, depending on the number, you have this color, that's a dictionary. Then you have the color of the cell number. This is the background color, or no, this is the text color, sorry. And this is the font of that color. All right, so I will just push this really quick so that you all have access to it. Add these. So now we're adding colors and fonts, and then git push. So you should all have access to that shortly. Let me just double check that it all updated. And it should have shortly. Okay, it did not. Hold on. Git add, git commit, and git push. Okay, I saved it this time, so it should have actually updated. There we go. So it should all be up in the GitHub now. Can you all see it? We just get a yes or no in the chat. So once you all have those resources, we can continue. And I'm just going to collapse all these for now, just so to keep it clean. Okay, awesome. Now that you all have that, next we need to actually make the GUI, right? So for that, we are going to just define a function called make a GUI. So def make underscore GUI, and then this would be, you pass self into it again. So what's going on here is you essentially want to create a 2D array, right? So this is going to be a 4x4 matrix, and you want to go through each row and each column and initialize each row and column cell to be completely empty. And this is where you're setting its height, you're setting the frames, you're setting the numbers, you're setting the padding, and essentially initializing everything for the initial GUI. All right. So the first thing we need to do is actually set the self.cells to, this is going to be an empty 2x2 matrix. All right. And then you want to, again, you'll have two nested for loops for I in range 4. You have each row. This is going to be an empty row column. And then for j in range, if I can spell, 4, this is going to be all the columns. So this is where you actually create each cell frame. And the cell frame is just, again, just initialization of each individual cell in the game. So if you all can see the game over here, each cell is just one of these squares in which one of these numbers lie, or one of these empty values are. All right, so we're going to create a cell frame, and this is going to be initialized using tk.frame. All right. Now, over here, the first thing it needs is just the main grid, because that's where it's going to be sort of taking place. So self.main grid. Okay, that's where it's going to be held. Next is just the background color. So background for this, we've already gotten all the backgrounds from the GitHub repo. So and then this is the empty cell color. So color_empty cell is going to be the background color of this. Then you have to set the width, and the width will set to 150 pixels, and the height as well to 150, as again, it is a square. All right, so this is just initialization. Now this is in the column row, right? Oh, I'm missing something here, tk frame. There's a comma there, no comma here. Okay, that should fix it. All right, next, right under this, inside of the second nested for loop, we also want to initialize each cell frame, right? So cell frame dot grid, and we're setting each cell to row equals I, right? And column equals j. So each cell frame goes into row I and column j, so that all of them are filled. And we want to pad it as well, so that it's not all jammed into each other. So the padding on the x value is going to be 5, and y is also going to be 5, so that it's even. All right. Next, we need to actually set the label for each of these cells. So this is the cell number, right? So each cell also has a number. It's going to be 2, 4, 8, 16, so on and so forth. So cell number is something else we can initialize. Number equals, and then again, we need to create a label, label. And this label, essentially, we're going to be passing the main grid self. I always forget the self main grid, and the background of this is going to be the color of an empty cell, because again, it is just the number of the cell. So pg equals the color. Oops, I'm missing something. And I'm definitely missing something. Self dot main grid equals self. That's what I'm missing. Always the selves. Don't forget your cells. Color and underscore empty cell. All right. Whew. Am I going too fast, or is this a good pace? Just let me know. I can slow down if needed, or speed up. Might have to speed up a little if we want to make it on time. But I can always push our code. Speed up, slow down. Just right. Fine. Okay, that's awesome. I guess we'll continue at this rate then. That's perfect. So now that we have the cell number, right, we want to also add that cell number to each location in the grid, right? So we have the frames, but now we need to add the numbers as well. So perfect, awesome. Each cell is going to be on the grid as well, and very similar to how we set the cell frames, we want to do the numbers as well. So cell underscore number dot grid, and we want to set this to row equals I and column equal J. Column equals J. All right. So now we have the cell numbers and the cell frames in their specific locations. Next, we want to actually hold all the data or all the information of the cell. And the best way to do this is in a dictionary. So we're going to create a cell data dictionary, and this is going to be, let's see, a two-part dictionary. So we have two parts in this dictionary. The first one is the frame, and the second one is the number. So each frame has a number that is associated with that frame. So a dictionary is what we're going to be using here. So let's create our frame, and the frame is going to be the cell frame that we just created earlier. And then we also have, again, our number, and this is going to be the cell number that we also created earlier. Okay, so now we have our dictionary initialized and ready to go. We have our cell numbers, we have our cell frames, and now all we need to do is obviously make sure we're actually appending this to the row data. So row dot append the cell data. So that's being appended to each row. And lastly, under the for loop, so this is under the first for loop, you want to append the row data to the cells. So self dot cells dot dot append, and you're appending the row data. All right, so this is the first part of the making the GUI. Now let's continue on to the second. So this is going to be obviously outside of the for loops. So make sure you exit the for loops in your IDE, and you will now be actually creating the score frame. So you have this, we have basically initialized everything over here. We've set all these things up. We've set the dictionary in which all this information is being held. Oh, thank you. We've set all the information where all this is being held. Now we need to create this area right here where the score is going to be. All right, so let's get right to that. So that would be under the score frame. So we can create a score frame. And this is going to be, again, another tkinter frame. So tk.frame, and obviously pass self into it, then score frame dot place, and this is where the score frame is going to be, so where the score is located, and relative x over here is going to be 0.5, so 0.5, and the y is going to be at 45, and then we're going to anchor this to the center. Okay. That will be the beginning of our score frame. Then we have the set. We have to set the actual label to make sure it updates. So tkinter.label, and this would be the score frame. That's what it's going to be. Location, comma, use the commas. Then text equals score. So that's essentially the text that you want above it. And lastly, the font that you want to choose for that. So we already have that preset, so y'all can just use that. So self dot, and this was font for the score label. Okay, now we want to set this to a grid, so we're snapping it into place, dot grid, and this is going to be the first thing in that row. So row 0. Okay, so this label is being set to a grid on the first row, and then we're going to have the actual score that's updating on the second row. All right, so that would be done like so, self.score label, score label. So we're actually setting the score label here, and this would be the tick hinter. Again, we want to set the label because this is going to be text. It's going to be located in the score frame. The starting text is going to be 0 because, again, we're starting with 0 points. And the font we already have set for you guys at font underscore score. Oh gosh, self dot font font underscore score. Okay, perfect. So that would be the font. And then lastly, you want to just set the score label and you want to lock this into place as well. So we lock this into row equals 0. Next, we're going to be locking this into the first row or the second row, index 1. So you would do that by setting the self dot score label dot grid. So in the grid, you want to set the score label to row equals 1. All right. And that should be it for your make GUI function. Now, obviously, you do need to pass or you need to call that function somewhere. So that will be right here, self dot make GUI. Okay. And that should be enough to make your GUI. Let's try this. Okay. All right. Any questions so far? Yes, no. I'm going to take a 5-second water break. Okay. Questions? Yes, no? Okay. If not, then we can get started on the next part, which is going to be 1 second. All right. The actual start game function. All right. So we've made the GUI. Next, we want to actually start this game. Let's see. So over here, we're going to create a new function called start game. And pass a self value. And over here, essentially what we want to do is we actually want to create the matrix. We want to initialize it to 0 for basically each part in the matrix. And then we want to choose some random row and column number. And for this column number and this row number, you basically want to add 2 or either add a 2 or add a 4, right? So this is just to start the game. Initially, when you're starting off the game, you can see that over here, there are 2 2s that get randomly placed on the screen. So this is sort of part of the initialization. This is one of the first things that happen. So that's essentially what we're going to be doing here. So to do this, we want to start game, pass a self value. So in the matrix, we can initialize a matrix value, and we want to set this to 0 for all rows and columns. So for all values in range 4. Okay. That sets our matrix. It's going to be an empty matrix right now. Now we want to set our row value to some random, we want to pick a random place in the grid to start off with the 2s, right? So the row value is going to be randomly selected. So this is where we can use the random library that we imported. So random.randint. We can pick a random integer from 0 to 3, which is 1 to 4, and then pick for the column, do the same thing. Column equals this. All right. Next, we want to set this self.matrix to 2, right? So this value is going to be 2. You can never start with a 4. You always start with a 2 in 2048. Whereas if you're in the middle of a game, then a 4 can spawn or a 2, either one of those. So in this case, because we have the, we're starting off, we want to set this matrix row and column to the number 2. Okay, and then you have self.cells. So each of the cells, again, now we need to update the frame numbers or the frame of the number in the dictionary earlier, and we need to set the configuration value. So we need to be like, okay, each one of these is going to have this number in it, and it's going to be painted this color. So that's essentially what we're going to be doing next. So for each cell at a specific row and column for the frame specifically, that's the frame dictionary that we initialized earlier, that is going to be configured to a background that has been predetermined. So that's self.color cells. There's this color cells, and we have the number 2 over here. So we'll pass in the 2 value. Okay. Next, we want to do the same thing with the number. So self.cells, right? And then row and column. Row, column. Take the number. And this is again going to be configured to all the information that we have predefined. So this is just a bunch of configuration stuff. Figure, and let's see. So first we need to set the background, and this is going to be to self.color cells to color cells 2, okay, comma foreground color, which is going to be set to the cell number. So this is just the color of the number of the cells, font color essentially. Let me stain it as formatting here. Foreground equals, and let's see, color cells 2, self, always start with cells, cell number, and this is cell number 2. And then do the same thing for the actual font that you're choosing. So font equals self.font. Which font is this? The cell number font. For 2, okay. And lastly, you want to update the actual text value that is in there to the number 2. Okay, perfect. Now, that would be the first one because you know it's an empty matrix. You can put the first number 2 wherever, and it doesn't matter where you place it because all spaces on the board are free. But for the second one, obviously not all spaces on the board are going to be free, so you need to check if you're clashing with that first space or not, right? So for that, you can just have a simple while statement. So while self dot matrix, and then check the row and check the column and check if it's not equal to 0. So if it isn't equal to 0, then you would need to reset basically this row and column value. So you can just copy and paste it over to here, right? So if it's not equal to 0, then you want to reset the row and column value, find a new row and column value. And once you've done that, then you can essentially do exactly the same thing that you've done over here. So self.matrix row columns 2, self cells row column. All this is still configured to the same thing because again, you have a new row and column number, so that'll update a new part in the, or a new place in the matrix. All right, so you can honestly just copy all of this over and paste it right down here. and that'll serve the same purpose. All right, and then of course you want to set the score, so score, and the score is going to be set to 0 initially because your score is still 0. Okay. Whew. That was a lot of coding in a very short amount of time. Any questions on that so far? Again, there's a lot of just initialization stuff that you need to do to work on this. So far what we've done is we've gotten the score header done, we've gotten the number, the labels, we've gotten the title done, and we've gotten this general grid, and we know how this matrix looks in the backend. So it's essentially a 2D array in the backend, and we have randomly placed 2 numbers. So we've randomly placed 2 number 2s. We set the background color to the same background color, or to white, because that's the background color of these 2s. We set the font color, and we've added these number 2s to these tiles. All right. That is what we have so far. Now, let me just add that. Wait, let me save it first. Okay. And this was start game function, so we've added that, and we can just push that. Got to push. Okay, perfect. So that should be up on GitHub now. So, we've gotten the score done. We've gotten all this stuff done. We have the UI. We have the start game. That is brilliant. So I can just collapse those now. Next, we need to do the actual matrix manipulation stuff, right? So we know what's going on, but when we are actually playing the game, different operations have to be done on the matrix itself, and then those operations will have to show on the front end. So we're first going to work on the operations specifically, because we know what those operations are. Then we're going to be working on how you essentially add new tiles to the game, and then just updating the UI. And then on each move, so when you hit the right arrow, which one of those happen in what order? When you hit the left arrow, which one of those happen in which order? We're going to be going over all that next. All right, so first things first is all the matrix manipulation stuff. So this might get slightly complicated, convoluted, but I will try to simplify it. So first thing, again, that we went over was that we needed to, for manipulation, we need to stack things, right? So imagine I have a gap between 2 numbers. So there's this, imagine this number 2 was shifted 1 to the left. I'd have this gap over here, this gap of 1 empty cube, right? So 1 empty tile. What I essentially wanted to do was stack them both on top of each other if these were different numbers. So that's what we're going to be doing next. So for stacking, that would just be define stack, right? And on self. And for this, we're going to essentially first create a new matrix, and this is going to be a completely empty matrix. We'll do all the stuff on this new matrix and then just set the original matrix values to this new matrix value. So for this matrix, essentially what we want to do to stack everything is just shift everything down 1, right? And so for that, what you want to do is first let's set the new matrix value. New matrix equals, and we're just doing the same thing that we did when we were starting off the game. So setting an empty matrix. That's new matrix. Then we want to go through it for I in range 4. You want to set a fill position. So this is where you're going to be basically shifting everything down. So fill position. Set it to 0 initially. Then for j in range 4, right? You want to first check if the matrix. So check if matrix at ij at location ij is equal to 0, right? So you want to make sure it's not equal to 0, so not an empty location, and if it's not an empty location, then only you stack on top of it, right? So if self.matrix is not equal to 0, right, then you want to set the new matrix at I comma fill position to the original matrix. Got it? So in this case, it would be new matrix at I and the fill position. Set that to self dot matrix at I j. Got it? And then you just want to increment the fill position by 1 each time so that you can keep moving it down. All right, so fill position, and then you just want to increment that plus equals 1. All right. And then you need to just, again, set the original matrix to the new matrix, and you want to do that outside of the loops and not outside of the function declaration. So that would be self.matrix equals the new matrix. All right, so that's it for stacking. The next matrix manipulation function we went over was combine, right? So if you have two values that are the same and you collapse them on top of each other, they need to combine into one, and that one doubles, then you have an empty spot that remains. So the parts to that are you need to actually first go through everything, and we can do this in a way that we only need to combine in one direction, then we can do different manipulation functions on top of this to basically change the direction in which it happens. So this will make more sense once I actually code it out. So let's actually create a combine function, pass self value into it. All right. So for this one, I'm going to go through for I in range 4. Again, we're always going through the matrix, but in this case, we are going through all the rows, but only 3 of the columns because we're going to be checking the one next to it, right? So j in range 3. Over here, what you want to do is you want to check, okay, if the matrix value at I comma j is not equal to 0, and this matrix value that's at I comma j is equal to the value of the matrix at I j comma or I comma j plus 1, right? Because you want to check if it's the same as the one that's adjacent to it. Then only you would double the one that is next to it, right? Otherwise, you would you just ignore it completely. So to put that into code, you're basically checking if self.matrix at I j, I'm gonna just copy this ij just so I don't need to keep writing it out, is not equal to 0, right? Because you want to make sure it actually has a number in there. And at the same time, self.matrix at ij again is the same as whatever is at self.matrix at I and j plus 1. All right, so this is the one adjacent to it. That's why we only went to range 3. Otherwise, we would have gone overflowed, right? So basically what we're going to be doing is stacking, and then we're going to do the stack. After the stack operation, we're going to see if the 2 are next to each other. And if they are, then combine it. Otherwise, we're just going to leave it at stack, right? So that's why you notice that we don't need to do anything too complicated, but it's actually a 2-step process to combine, because first you need to stack and then combine. And this is a check operation. All right, so if this is true, then what you want to do is you want to set the value at I comma j to double, right? So self dot matrix at I comma j is doubled. So you can just times equals 2 for that. Okay. And then you want to also make sure you reset the value of the other one. So self.matrix at well, that is not matrix I comma j plus 1. So the other one needs to be set to 0, right? So it's being reinitialized initially. And once that's done, you want to update the score as well. Because the person got one combined, that'll increase their score. So self.score plus equals self.matrix. And this will be at ij. So this is just increasing the score by the amount that they have combined. Okay, that is it for the combine function. Any questions on combine or stack, just let me know in the chat, all right? Next, what we want to do is reverse, right? So as we wrote over here, we need to do a reversal of these as well. If we're doing combine, but we're doing it in a different direction, then we want to make sure that is also being done. Or we're stacking, but we're stacking in a direction other than the one that's been explicitly mentioned. We also want to make sure that's being done as well. So for this, we're just going to, again, create a new matrix, go through the matrix, and just flip everything around. And this is a pretty easy function. It's pretty easy to follow. So def reverse, and again, pass self value into it. And that is not how you spell reverse. Reverse, there we go. Create a new matrix, and this is going to be an empty matrix. Next, you want to obviously loop through for I in range for new matrix dot append, and you're just appending an empty value to that. Next, you want to go through each j in here. So this is essentially another way of just doing the same thing that was, where is it, up here. You can also do this if that looks better, or you can append just another 2D array inside of it. So I in range 4, new matrix of append dot for j, you want to loop through j in range 4. You can also just, this is where you're actually flipping everything. So new matrix at I dot append, and here you would be appending the actual matrix and then just the inverse of that. So 3 minus j, so that everything gets flipped over. So that would be what, self dot matrix at I, comma 3 minus j for each. All right, and then of course you need to set the initial matrix or the original matrix to the value of the new matrix. So self dot matrix equals new matrix. All right. Whew. And that is it for the reverse function. Now we got one last matrix manipulation function left, then it'll get a little bit more fun because you're actually doing things that are that affect the code or that affect the GUI. So lastly, we want to do transpose functions, and these functions will be for when you are essentially moving up or down to transpose the matrix into itself. So to do this, you will again define a function called transpose pass self value. Next, you want to set a new matrix. Honestly, let me just copy paste this. Initialize a new matrix. So this will be an empty matrix. And for I in range 4, and for j in range 4. What you want to do here is you basically want to set the new matrix ij to the initial matrix ji. So you're just flipping it over its diagonal. New matrix was ij equals original matrix self.matrix at j comma I. Okay, and then obviously you need to set the initial matrix so to the new matrix self.matrix equals new matrix. All right, now that matrix has been set. Ooh, that is it for all of the matrix manipulation functions. So we are at a good 160 lines of code now. That's pretty solid. But we are still nowhere near done. Actually, let me add this. Did I save this? No, I didn't. Okay. And that has all been pushed. So you should have access to that now as well. Okay. Now that we've done all of these matrix manipulation functions, something we need to do is check if we're able to actually add tiles, right? So we need to randomly add tiles during the game as well. So just wherever there is space, add a tile that is either the tile 2 or the tile 4. So for this one, it would be a pretty simple function. So add a tile, let's say add new tile, pass self value, okay? And again, this is in a random row and a random column. You want to check if there's anything in that random row or that random column. If there is, then you keep looking for a spot that's free. And if there isn't, then you can either put a 2 or a 4, and you can choose randomly. And we actually did do something very similar to this in the start game function, right? So we can honestly just copy some of that over. So this whole row and column rand_int work right here. We can copy that over. So now we have a randomly selected row and column location. Now we want to check. So while the self dot made, no, this is not in the parentheses. Self dot matrix at row and column is not equal to 0. So this is while there is something there, then you want to, again, keep looking for a place to put the tile. And because this is during the game, you only spawn one tile, right? So 1 or 2, so it could be either. In this case, you would check if there is a spot open, and if there is, then you would update the matrix, self.matrix, and at the location of row and column, you want to either put a 2 or a 4. So the way you can do this is use the random function, random.rand, or this wouldn't be random, this would be random.choice. And then you just have it choose from either the number 2 or the number 4, and that will be generated randomly. Okay, that is it for adding a brand new tile to your screen. Actually, I'll keep that open. Next, what we want to do is update the UI. So every time the matrix is updated, it's still only being updated in the backend. Nothing's happening on the UI front to show you that that thing has been updated. And you might remember how we did all the initialization here for making the GUI. It's going to be somewhat similar to that, only it's going to be more generic or generalized so that this can be used for any number instead of just the number 2. All right, so let's do that now. Also, if there are, again, any questions, just put them in the chat and I will get right to them. Okay. Next is just the updating GUI, right? So update underscore GUI, and this would be on self, pass self to it. Now for this, again, you need to check every column and every row. So you'd be going through each row, each column, checking the cell value. And there's two things that can happen. Now, if the cell value is 0, then you keep it empty, right? and there's no text in there. Otherwise, if there is um, something in there, right? So the cell value is not 0, which means it's 2, 4, 6, 8, and so on. Then you want to change the cell value so that it matches the colors, the numbers, and the fonts and the font color for each of those numbers, because each of that is different, right? So we can do that real quick. So for I in range 4, again, this is very similar to the setup. For J in range 4, this is going through each tile. You want to see the cell value, right? So the cell value in this case would be the matrix value at I comma j. So self dot matrix at I comma j. Now you want to check, right? If the cell value is 0, then you do certain things. Otherwise, you do other things. So let's see. If the cell value is equal to 0, so you want to check if it's equal to 0, then you're going to be setting essentially the frame, configuring the number, and then you do the same thing if the cell value is not 0, but you'd be doing it to a more generic extent. Hello, Adam. Let's see. So for when it's 0, then you want to set the cells. This is very similar to what we did here in Make GUI. Let's see. Here it is. So in this case, we would be setting self dot cells at ij, cells at I comma j, and this would be the frame specifically. This will be configured to the color of an empty cell. So background equals self dot color empty cell. All right. And then you also want to update all the number information. So very similar to this, ij, just copy that over. And number. Now this will be configured to, let's see, the first one, the background, and that will be the color of an empty cell, and text is going to be blank. So background equals self dot color of empty cell, comma, text equals empty text. Okay, perfect. Now that is what an empty cell looks like. And if a cell value is not equal to 0, then you need to do something else. So else, it's just, we can copy this part over, but we're just going to be changing everything that's inside to be from empty to making it generic, so that it can cover every number that you can possibly get up to 2048, right? So for this one, you want to configure the self.color cells, this one over here, there. Let's see, we can actually put this in a new line just to make it look cleaner. Okay, so for this one, you want to set self dot, this would be color of the cells. So this is the big dictionary of numbers and colors that we had earlier. And this would be set to essentially the cell value. This is the number that's in the cell. So cell value gets passed into here, and same thing or similar thing over here. So the background would be self dot color cells, cell value. Oops. There you go. Cell value, comma, and then you'd have the foreground or the font color, FG equal to, this is going to be the color of the cell number, self dot color cell number, and then pass the cell value. And then you want to pass in the font. So font equals self dot, and then what was the font? Font cell number font, okay, and cell value. And lastly, of course, the text. So the text in this would be equal to stringify, let's see, the cell value. Okay, so that would be it for updating the GUI. Then we've gotten all that. Next, we need to update, what else is there? The score. So the score obviously needs to be updated outside of the for loops. So self.score. This would be the label. So we can just write the score label, configure this to be at text equals self.score. Okay, so this is just setting the score label to whatever the score is, right? And then you want to just update all tasks. This is just a GUI update thing that's in tkinter. So it would be self.update idle. Where do I go? Update idle tasks. There we go. Okay, and that is about it for updating the GUI. So now, anytime there is a move, you check all the cells, see if they're empty, you color them empty. Otherwise, if there's a number in them, you color them and set them up according to their number. All right, I'm going to add this to the GitHub link. Did I save it this time? I did. Changes. I'm not going to be too detailed here. And there we go. It should all have been pushed now, so you should all have access to that. All right, so we've done most of what we needed to, right? So we finished fonts and colors, key bindings, all UI work. We have the matrix, numbers and score updates, start game initialization, adding tiles randomly. So what we have left is checking if the game is over. We have the UI done, we have the matrix manipulation functions done. So we're actually doing pretty well on time. All right, so next what we need to do is actually do all the different moves, right? So ability to move left, right, up, and down. That's something we need to take care of next. So let's get right into that. All right, so we can start with left. And again, each one of these directions in which we move is going to have a different way in which it happens, right? So for instance, if we were going left and we had self passed into it, we need to first stack. So we're moving everything to the left. So we're first making sure everything gets stacked, right? So self.stack. Because again, the stack was created with left move in mind, right? So it was initially made for left move, whereas for right, we'd probably have to first call a reverse, then call a stack. So you want to stack, check if you can combine, so self.combine. And if you can, that's great. If you can't, then you want to, again, check the stack, self.stack. And let's see, once that's done, that's going to take care of everything that's needs to be done on that. You also need to add a new tile, so we need to call that self.add new tile. That gets called. So now you have a new tile over there, or two new tiles. Then you need to actually update the UI, so update the front end with all that information. So self.update GUI. We call that function, and then we need to, well, we would need to check if the game is over, but we'll get to that function in a bit. Okay. So looks like we're doing pretty good over here, but we had to call the start game function. We should probably do that as well. So that would be start game. Self dot start game. Okay, so that's it for the initialization. So now we have the GUI and we have the start game function that's been taken care of. We know how to add tiles. We know how to update the GUI. Next, okay, I've gotten to the left. Now let's do right. So if I move to the right, then it's very similar to what would happen if I'm on the left, but again, it'll have to be reversed because I am moving things to the right. So for this, we actually start with a reverse, self.reverse. Oops, not register, reverse, I can't spell. There we go. So first we reverse, then we would want to do basically what we do in the left, right? So self.stack. Then we want to see if anything combines, so self.combine. And then because everything is left aligned, we need to reverse it. So we've reversed it, we've stacked, we've combined, and we need to actually stack again to make sure that there's nothing left. So self.stack. And once we've stacked, we need to reverse again because again, stack is happening in the opposite direction. So self.reverse. And then we need to, again, just add a new tile, update the UI, and that would be it. So self.update add tile. Whoa, not a software update. Okay, that's been taken care of. Okay, we need to update the GUI. And lastly, wait, no, that's it. Reverse update GUI. Am I missing something? Stack, adding a tile. That is very important. Add new tile. Okay, awesome. So that is left and right. Now for up and down, that's when you actually need to use the transpose because again, you're flipping the matrix on itself. So let's see, we can start with up. Pass self. Then for this, again, it's transposed and very similar to everything else. Stack, combine, stack, combine, and stack again, right? Then transpose, then adding a tile, then updating the GUI. So it's very similar to right. We can honestly just copy paste that. V, so instead of reverse, this would be transpose. Self.transpose over here, self.stack, then self.combine, then self.stack again, then self.transpose, and we add a tile and we update the UI. Okay. And then lastly, left, right, up, and of course, down. Now this one is going to be interesting because it's a combination of a transpose and a reverse, right? So this is essentially combining the up and the right one so that everything's being flipped on itself. So for this, essentially you would want to do all of this, everything's an up, but instead of, or after each transpose, you just self.reverse, okay? So you have a transpose, reverse, stack, combine, then you have a stack, and then you have to reverse and then transpose, and then you can add tile and update the GUI. So stack, and then again reverse, self.reverse, transpose, add tile, and update the UI. Okay, so that was a lot of complicated logic for this game, but that is what's necessary. Okay, let me up and down, left to right. Okay, that should have been submitted. Let's see. 40 insertions. Okay, that's good. All right, we are at 244 lines of code. and we are very near done. All right. So now that we've done, let's see, we've taken care of our ability to move, we've taken care of starting game, updating the scores, everything before this, randomly adding tiles is done. Next, we need to actually check if the game is over, right? So the game is over if a user gets a 2048 tile, which is a win, or there are no moves possible. So we can actually break down this no moves possible into smaller parts. So there are no vertical moves possible, or there are no horizontal moves possible. So no vert moves, or no horizontal moves, right? So we can actually write functions to check if there are vertical or horizontal moves. So start with horizontal, just because that's on. Let me collapse all of these. So we are now working on check if horizontal move exists. So move exists, and we are passing a self, of course. So for this, we're essentially checking if there's anything to the right or left that, or if there's any room to the right or to the left, which can be moved to, right? So in this case, we just go for I in range 4, and for J in range, this would be 3 because it's columns, right? So you're only checking 3 columns. You want to check if the matrix at ij is equal to the matrix at ij plus 1, right? So if the matrix at ij is equivalent to matrix at I and j plus 1. Again, j plus 1 is the reason why we are only going to range 3. And if that is the case, then you are going to return true, because that means a horizontal move does exist, right? Otherwise, you're going to return false. So basically what this is doing is it's checking if something can be collapsed into itself. And if it can, that means a horizontal move does exist, and that's going to return true. But if there is something which doesn't line up with the thing to its right, then you're going to be removing false, right? And you want to do the same thing vertically. So vertical move exists is what you're checking here on itself. And here's for I in range, this would be 3 this time because you're checking if a vertical move exists this time around. And then for j in range 4, now again, you're checking if the matrix at ij equals the matrix at I plus 1j, return true, otherwise return false. So you can honestly just copy paste this over. If matrix ij is I plus 1, and you can remove the plus 1 after the j, and you want to, well, what's going on here? What is the issue? Oh, I in. That is not fun. Okay, for I in range 3, for j in range 4, if the matrix ij is equal to, so there is a vertical move, return true, otherwise return false. And now we can actually just do the logic to check if the game is over, right? And then we are basically done. Wow. So we want to check if game over, correct? And obviously pass self. So if the game is over, you want to check, first of all, if there is a 2048. So this is if you won. You want to check if there's a 2048 in any row. Then you just put up a banner saying, hey, you won. Otherwise, if there is no zeros left and there's no vertical move that exists and there's no horizontal move that exists, then you're going to say you lost or game over. right? So to do that, we can start off with the win condition. So if there's any number that matches 2048 in a row for each row in the matrix, then you want to, this is just us creating a frame, essentially, where we're saying game over, right? So we can have a game over frame. This would be the takeInter.frame. And over here, you basically just want to initialize it to self and border with, I don't know, equal to 2. Border equal to 2. Okay. And then the actual location, this is just where it's going to be fixed, very similar to how we had to do all the fixing for the score label. That would just be the game over frame and just location, so that would be that place, I believe. That place, and relative x is going to be at 0.5, so 0.5, and relative y is going to be at 0.5 as well, because this is going to be fixed to the center. So 0.5, and lastly, you want to anchor it to the center. All right, so that is the game over frame. This is locked into 0.5 relative and anchored to the center. Then you want to actually initialize the label, so tk.label at, this is going to be the game over frame, is going to be where it's at. This text is going to be, because you want, you can write text equals you win, yay. Otherwise, let's see, wait, before we get there, let me move this down so it's easier to see. Okay, text is you win, then you just send the background, the color, and the font, right? So BG background color is, let's just set this to any dot color background, oops, commas, and then FG equals self dot color, and this would be foreground, that's FG, comma, let's see, next you want to select the font. Font equals self.font, and this would be the game over font. What is this? Font game over. There we go. And this is just .pack. So this is going to be sent. Okay. So that's how you set the label for if you won the game. Now, again, the label for if you lose the game is going to be very similar. So we can just write an else actually. But we want to check first if the game is over or it isn't. So in this case, it would be else if there is no 0 left, so there's no empty spaces. 0 in this row, very similar to this, for row in self.matrix. All right, and then that's checking if there's a 0 in there. And then we also want to check if there's any vertical or horizontal moves, right? So in this case, and not self dot horizontal move exists, and not self vertical move exists. Okay, so if none of that is the case, that means you lost, and there, or the user lost, the player lost, and there's no other moves left to make. So in this case, we just set the game over frame to very similar to this, tk frame self border equals 2, then relative X, Y anchored at center, and the label is still going to be the game over frame. You could just change the text to you lose. Background doesn't matter, foreground doesn't matter, and the font does not matter. So let's do that real quick. Just copy and paste that over and change the text to you lost. Or let's make it slightly nicer, sound a little bit kinder. Game over. Okay. All right, and that should be about it. All right, so let me push all of that over. All right, any questions on that so far? Yes, no? Questions, comments, concerns? This should all run perfectly, and if you actually run it, then you should be a 2048 game that pops up. Let's see if all this works. 2460, the score mechanism seems to be working, so let's see, we're at 60. We're going to merge a 4 and an 8. That goes up to 84. Okay, that's correct. Every time we make a move, there is either a 4 or a 2 that spawns, and only one of them. And when we initially start the game, then there were 2 tiles. There are 2 2s that spawned on here. Okay, this actually looks correct. Nice. Okay, any questions on that? Any concerns? Are you all able to follow? Are we all able to get it working? Let's just go do either lose a game or go to 2048 to make sure that all the edge cases are also taken into account. But yeah, this is great. All right. It seems to be working. That is awesome. Now, have any of y'all finished actually creating the game, coding it up? Just put it in the chat if you have or have not. And if you're having any issues, let me know. I am here to help. Can't see the latest code. Oh yeah, let me do that real quick. Let me push everything. Git. Is this all saved? Yes, it is. Okay, let's add everything. Git add. Git commit. Finish the game. And git push. Oh, I cannot see this. Git push. Okay. Whoops. Let's move on. Okay, there we go. It should be. Hello, can y'all see me? Okay, perfect. That just kicked me out real quick. Nice. Let me rejoin, share on my screen. Screen one. Awesome, awesome. So now you all can see it completely, or it should be working fully. Let's try to run it. And there we go. We do get it running fully well. Let me try breaking this. But yeah, let's see if you guys can also play the game a little bit. See if you can get to 2048 tile. See if y'all can break it. But this is the game. This is all right. Any questions? Anyone struggling with anything? Having some trouble? I'm here to help. Want some explanation on what a certain piece of the code does, because I know it could be, or did get a little confusing at times. Just let me know. Y'all can put it in the chat. But in the meantime, I'm going to be playing this game that we just built. And I think I lost. Wait. Okay, I'm still up. That's not good. Okay. All right, you guys. No questions, no comments, no concerns. Y'all are just gonna watch me lose. Okay. Let's see. Look at that save. Oh, you cannot see the screen. Oh gosh, I'm sorry. There we go. Now y'all can see me lose this game. Yeah, but it is fully working. And again, if there's any questions, any comments on anything at all, feel free to let me know. Were y'all able to get it working on your devices? Thank you, Indigo Wizard. Final adjustments. Okay, that's good. How about everyone else? Y'all able to get it working? Just fine. Oh, you just need to hit the run button. So you should just run it. Let's see. So if you're in VS Code, I am on a Mac, so I have the little touch bar thing. But you can go up here, just run without debugging, and it should pop up. If you're on a Mac, if you're on a Windows, then I believe this should also run it. There you go. So there's a little run button over there. You just need to hit that, and it should run, and everything should work. Okay, let me try and get a 2040 this time. The trick is to stay in the corner. Okay, that's awesome. Great work, Indigo Wizard. The trick to 204 is just stay in a corner and don't stray too far away from there. So as long as your biggest number is in the corner, it's usually pretty easy because you can just move things around to get things to it, to get numbers to it. That's awesome, Indigo Wizard. Just make sure to go to 2048 at least once and just try to lose the game once. And if you're able to do that and it runs both times without any error, then you know it's completely error free. And that's what we're going for. So that's what I'm doing right now. This isn't me playing the game, this is just debugging. Okay, this is a tricky one. All right, how about everyone else? Is it working for you guys? Do y'all need any help? Any code explanations? Anything at all, I'm here for you. Okay, that was actually pretty good. Let's see. Okay, save yourselves there. We're at 512, almost there. We just need to keep going. Anyone else in the chat? Is it able to work for you guys? Indigo Wizard, how's it working for you? Were you able to get to either a 2048 or end the game? One of those two? Oh, there we go. I got to a game over. And it shows that perfectly fine, so that's good. Now, I just need to make sure the 2048 works, but that takes a while. And crashed, interesting. Was it during the game or after? Because if it crashed during the game, that would be strange. And relaunched a second time. Interesting. We didn't have like we didn't handle the ending of the game very well because I think it's just, let's see, if game over, then the game's just over, right? Yeah, it just ends the game, puts a label on top of there. So it looks like if actually you have a 2048 or you get a 2048, you can actually continue playing, but the label over here does not disappear. Interesting. That's what the code looks like. But this is great. Congratulations, you just made a game of 2048, a black rectangle. So is the entire thing a black rectangle? Cyclops Budgie. The question was, or was this the black rectangle for some reason? That means the tiles aren't actually showing. So there's an issue with when you're actually displaying all the tiles and their colors. So are you able to see the numbers as well, or just a black rectangle that shows up? Just a rectangle. And does it have a title as well? Oh, okay. So actually, that would happen if I guess you don't have any of this. And that's just this background color over here that's being shown, right? So it's this dark, you said dark gray or black rectangle. Um, that would be this initialization right here. So it looks like none of the other things are being executed properly. So is the make GUI function working for you? You just need to, I guess, debug it, check like line by line against this, see where you might have gone wrong or where I might have gone wrong. But it's an update GUI. This is where actually all the cells are getting their color value, right? So you can check this update GUI and this create GUI, or the start game actually. So start game is where you can see everything is getting its color. And did you also make sure to copy paste all of these fonts and colors from the GitHub? Because that could also be another issue. So these are the colors of each of the cells and the colors of each of the cell numbers and the fonts for each cell number. And then just some general fonts and colors over here as well. Okay, interesting. Let's see what the issue might be then, because if I actually comment out everything over here, so I commented that out and these. See what happens when I run this. It should have come up with a GUI. Let's see. Oh, wait, hold on. Left all these. Does it look like this, or is it completely empty? Like you don't even see this grid over here. Completely empty. So that means the make GUI function isn't being called. Are you calling the make GUI and the start game functions in the init? So when you're initializing it after the main grid, you need to call the make GUI and the start game. So that's these two lines right here. Interesting. So the make GUI should be called then. And in this make GUI function, are you able to find the place where you're actually creating the tiles? So that's just this right here. Creating all the empty cells and coloring them, especially this one, the frame and the colors. All this is in there. Because this might be the reason why it's not showing up. Otherwise, if we're still not able to find it or figure it out, then we can always just hop onto a Discord call. You can see me on Discord. I was the one that put the latest actually announcement for Global Hack Week about the 2048. You can find me on Discord, send me a message, and we can try to figure it out there. Awesome. You're welcome. I'll be on there in like 2 minutes. And everyone else, does it work for you all? It all looks great. You all can put this on your portfolio, show it off, play when you're bored. But this is the 2048 game, and I'm glad you all could join me for this today. All right. I'll be signing off in 2 minutes, but if you all have any additional questions or any follow-up questions or want to know how something works, just shoot me a message on Discord and I will let you know. Resize because 150 goes off of screen. Over here for each cell, oh, that's fair. I think I might have a slightly larger screen, but that's pretty good. Resize 150 goes over screen. Interesting. Did you initialize the width and height to 800 each? That could be, oh, interesting. Because, yeah, it does look fine online. So which part of the screen went over? So it was just the tiles themselves? 150 to 100. All right. Let's do that. See how it looks with 100. Yeah, this is much smaller on my screen, but it still looks pretty good. Much larger text, or the font looks much larger relative to the tiles. I kind of like this compact look. Looks pretty good. Um, but I think I'm going to stick with 115 just because it's larger, gives you more breathing room. That's cool. That's cool. All right. Thank you guys so much. I'll be heading out. All right. And again, thank you all so much for joining me. If you all have any questions, shoot me a message on the Discord, uh, and I will try to get back to you. All right. Thank you. Bye, guys.